All right, we have now come to what is potentially the nastiest part of the section. All right, the limit definition of the derivative. So here's what we know about the derivative so far. The derivative is just the slope. And the slope of the graph is the slope of the tangent line. Derivative is slope. Always associate those two words in your head for this whole semester. Okay? And we've shown you a little bit about how to take the derivative, how to find the derivative, how to find the slope function with what we called was the power rule. Okay? Well, I am right about to blow your minds because the power rule was great, but I'm going to show you how to find the derivative of literally any function if it exists. Okay? So, you know, there's the power rule, there's the chain rule, there's the product rule, the quotient rule. Technically don't need any of them. We'll talk about the other ones in the future, as long as you have this one. If it sounds too good to be true, it's because it is. All right, I haven't lied to you though. Merely misrepresented the truth. Definition. The derivative f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. There you go. That's how you find the derivative of any function. Now this looks kind of intimidating, but don't worry, it gets worse. All right, so this really goes back to the fact that derivative is slope. And this is slope, right? What is slope if not rise over run? I wonder if my Apple Pencil is dying. Look at this. This is just the difference between two function values. That's a vertical difference. That's a rise, difference between two function values. And right here is if those x values are h units apart. This is our run, right? If one x value is this and the other x value is this, what's the difference between those x values? It's h. So this definition of the derivative really is just rise over run. As h gets really close to 0, and there's some really cool stuff with like secant lines and tangent lines, and we're not going to get into that too much. But here's what we've got. So let's get into some really, really interesting stuff with this. With example 4. All right. So find the derivative. Ooh, that's supposed to be an x. Find f prime of x for the following. Part A, f of x equals x squared. At this point, you should already know the answer. You say, ooh, Jason, I know this, the power rule. We're going to take that exponent down and then subtract the power, and we're going to get the derivative is 2x. And that's correct. Let's use the definition of the derivative, and let's see what happens. So f prime of x, we said, was the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so let's go off to the side real quick. F of x is equal to x squared. What is f of x plus h? Well, that's just f of x, but plug in x plus h instead of x. So this is going to be x plus h squared. Just like if I asked you what is f of 2, you'd plug in 2. What's f of 3? You'd plug in 3. Well, f of x plus h, you just plug in x plus h. So let's plug that in and see what we have here. So this is going to become the limit as h goes to 0. This first term we just said was x plus h squared. The second term, well, f of x is just x squared. And the denominator is equal to h. So you might get really, really excited here and say, ooh, Jason, I've been doing good with my limit properties. This is a rational function. So rational function, we can just plug in h equals 0 and get the limit. The sad news is that if you plug in h equals 0 here, you're going to get 0 over 0, which is no good. So if we plugged it in, we get 0 over 0. So we have to keep simplifying. All right. So let me just make a little comment about that. If we plugged in h equals 0, we get 0 over 0, which just like in the last video is no good. So we need to simplify. So it was too good to be true, but I'm very proud of you for thinking of those limit properties. All right, so let's keep simplifying. Remember that this guy up here, that's not x squared plus h squared. You have to FOIL that out. All right, so if we FOIL out that first term, and you can do it the long way, at this point, I'm going to do the shortcut for FOILing out perfect squares. This becomes x squared plus 2 times their product, which is xh, plus the last thing squared, all divided by h, the denominator, just like we had. So remember, right, that all I did was expanded this, and it became this. Everything else is the same. Okay? And now you should get a little excited, a little happy. Your lips should curl upwards. Your eyes should get a little brighter because you're going to say, what do we have? We have an x squared minus an x squared. I know what that is. Those cancel. Plus x squared minus x squared. These guys cancel right here. So all we're left with is this part with the limit. Let's see what that looks like. It's going to be the limit as h approaches 0 of 2xh, and it was plus h squared, right? It won't turn out to matter, but yeah, plus h squared all over h. And we're going to get into a very similar situation as before in the last video. Because again, if you plug in h equals 0, you're going to get 0 is 0 over 0, which is no good. But what did we do in the last video? We factored and canceled. We're going to do the same thing here. Okay? Let's factor and cancel. And yeah, I always abbreviate simplify with simp. But in 2021, simp can also mean other things. But I don't think I'm ever going to change. So let's factor. The limit as h goes to 0. What factors out of the top? The greatest common factor is h. And we're left with 2x plus h. On the bottom, we just have the h down there. Ooh, we factored. Those h's are going to cancel, and that's exciting. Because once they cancel, what are we left with? The limit as h approaches 0, 2x plus h. We no longer have 0 over 0 situation. We can now plug in h equals 0 because this function is now continuous. So as h approaches 0, we get 2x plus 0, which is just 2x. What were we doing? Let's wind this back. We got the answer, but what were we actually doing? We were trying to find the derivative of x squared. So we used the definition of the derivative, simplified, evaluated, and after a lot of work, we said the derivative is equal to 2x. Well, that's exactly what the power rule tells us. All right, so we expected this from the power rule. And this is the actual definition of the derivative. This definition, this formula, can calculate the derivative of any function. Just as you will see, it can be very tedious and sometimes impossible. But not impossible for you guys. I will not ask you any impossible questions in this class. But yeah, there are some functions where you use that definition and you just go, that's great, interesting. So there are some tricks to these, and that's what the next two examples are going to be on. So at this point, if you're good with this, go ahead and start working on the problems. If you want to see some of the trickier examples for these definition of the derivative problems, then stay tuned for the rest of the video. Or maybe pause, do some problems, and then unpause and come back right here, okay? So there are some trickier functions and some tricks that are going to pop up a lot with rationals, fractions, and radicals, square roots. Let's get on to see some of that. Part B. Find the derivative of this function. So again, put on your good math student hat and say, I already know the derivative of this function, right? This function can be rewritten, the radical can be rewritten as a rational exponent. The square root is the same as an exponent of 1/2. And then we could just use the power rule. Bring the power down, the 1/2 comes out in front, subtract 1 from the exponent. And you could rewrite this as 1 over 2 times the square root of x, because negative exponent means the x goes into the denominator. So at this point, you could use the power rule, and you already know the answer. But I'm going to show you where this comes from. We're going to use the definition of the derivative. And if you're worried about remembering this, because again, it can be a little tricky, f prime of x is equal to the limit as x goes to 0. Ooh, the limit as h goes to 0 of f of x plus h minus f of x all over h. I will give this to you on the quiz, okay? I can almost guarantee there will be one of these on the quiz. There's a small chance that there won't be, but I will give you this formula. But you have to know how to use it. You have to know how to simplify. And knowing the power rule helps because you know where you're supposed to go. But I will need all of these steps right here, okay? So be on the lookout for that on the quiz this week. All right, so let's do the same thing we did last time. So again, just like before, right, f of x is equal to the square root of x. So f of x plus h is equal to the square root of x plus h. We're just going to copy this down. The limit as h goes to 0 of f of x plus h, we said is that. So replace it. The square root of x plus h minus f of x. Well, f of x is equal to the square root of x all over h. And again, we get the same thing as before, but it's different. Same but different, yes. If we plugged in h is equal to 0, we'd get 0 divided by 0. That's no good. We have to simplify first. But it's really hard to simplify this numerator because we can't combine these square roots. A square root plus another square root can only be combined if the radicand, the inside of the square root, is the same. So we can't combine these yet. So there's a trick. Anytime you see a square root in these definition of the derivative ones, you're going to use the same trick. Here's what we're going to do in yellow. We're going to multiply by the conjugate of the numerator. Think all the way back to complex numbers and stuff. If we multiply a binomial by almost the same thing, but just switch the sign, so instead of their difference, we're going to multiply by their sum, we get a difference of squares scenario that essentially is going to eliminate these square roots. So this is what we're going to do in all of these square root situations in this section, so watch out for it. But if we multiply it on the top, we have to also multiply it on the bottom. And so this is where I warned you that algebra skills are going to be really important here, okay? You need to put on your best algebra student hat. So on the top, we have to FOIL this out. Remember FOIL, right? First, outer, inner, last. You have 4 things because it's 2 binomials multiplied by each other. But again, this is also that difference of squares situation where it simplifies to just the first thing squared minus the second thing squared. Again, algebra is going to be really key for this class. If you're feeling a little unsure on your algebra, reach out to me and I can give you some things to practice for this stuff. Or I can give you some refresher materials, some videos, and some web pages that have examples as well. Okay, so please contact me if you feel a little nervous about your algebra skills, because it's nothing to be ashamed of either. People forget math. Sometimes if I don't teach a math course for 2 years, I forget the stuff in the class too. And you just have to go back and remember it. Like everyone does it. Everyone forgets. So don't be embarrassed if you forget. So this is essential. This is, I say essentially so frequently, right? This is like a minus b times a plus b. And we know that if we multiply this, this is called the difference of squares. We get a squared minus b squared. So the first thing squared is x plus h squared. The second thing squared is the square root of x squared. All right. That's a squared minus b squared. And the bottom, we don't have to FOIL. The bottom is distributing. We have to distribute that h. Or we can just leave it factored. We actually don't need to multiply it here. If you wanted to multiply it though, that works perfectly fine. It's just optional. So x plus h plus the square root of x. And the reason why we're doing this is we're trying to simplify it. And I know it doesn't look simple. It looks worse, but it will get better. Because when we square that first thing, the square root and the squared cancel. We're just left with x plus h on the top. Right? This thing simplifies just to x plus h. This thing simplifies just to x. So we have minus an x. And the denominator, let's not simplify the denominator. Let's just hold our breaths with the denominator real quick. H times those square roots. All right, it's a plus. Whew. The hard work is done. We're almost finished with the problem. Because we have the beautiful thing that we love to see on the numerator. We have a plus x and we have a minus x. Plus x minus x, they cancel out. And look at this juicy, juicy place that we've gotten. The numerator only has an h. The denominator has an h times those square roots. And again, the square roots look ugly, but it's not too bad. We have a fraction that's fully factored. And in the numerator, we have a factor of h. In the denominator, we have a factor of h, and boom. There are no more h's in the numerator. Check this out. What do we have? The limit as h goes to 0. Remember, when things cancel, they become 1. The denominator is the square root of x plus h plus the square root of x. There's no more 0 over 0 situation because the numerator only has a 1. It's time to plug in h equals 0. Okay? So when we plug in h equals 0, we get 1 divided by the square root of x plus 0 plus the square root of x. Well, the square root of x plus 0 is just the square root of x. We have 1 square root of x on the bottom plus another square root of x on the bottom. That means we have 2 square roots of x. And by George, by golly gee whiz, that's what we expected from the power rule. Look all the way back to the previous one. We said the derivative better be 1 over 2 root x. And indeed, we got there. Cool, right? It's a messy puzzle. It's like one of those puzzle cubes that it's like a pretty cube and you take away all the pieces and it looks like a mess and you have to try to put them back together. That's what we did here. All right. It looked a little dicey in the middle, but by the end, we got where we wanted. All right, one more example, just again to show another trick from algebra that you may or may not have forgotten. So we have got a lot of extra examples in this video, so it's going to be a little longer than normal, but should be okay. The videos are all optional in the first place. Hopefully this will provide good resources for those of you who want them. Find f prime of 2 for f of x equals 1 over x. So this one's a little different than before. We need to find the derivative still. Derivative, slope. But instead of finding the derivative for any x, right, we found that the derivative for any x was 1 over 2 root x. This was the derivative for anything. It was the slope function. Okay. Well, we don't care about the slope function now. We only care about the slope at this specific point. All right. It's going to be very similar. So f prime of x, right, is equal to f, the limit, I keep forgetting my limits. The limit as h goes to 0 of f of x plus h minus f of x all over h. But we don't care about the slope at any x. We only care about the slope at 2. So let's look at f prime of 2. Plug in, replace all of the x's with 2's. Right? This is the formula for any x. So for 2, put in a 2. Going to be the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. So again, just replace x with 2. And I promised at the beginning of the day, we're going to have 2's everywhere today. I'm not lying. Not yet anyway. Okay. So, and once we get here, it's the exact same as example 4. All right. Except we have a rational function now, so it's a little different. So now I'm lying to you. All right. Whew. Here we go. Off to the side, maybe, if you want. You can say, well, f of x is equal to 1 over x. So f of 2 plus h, replace the x with 2 plus h. So this is what we're going to have to plug in to that first guy, 1 over 2 plus h. All right, and I don't actually have room to write this here, so goodbye. So we're going to have the limit as h goes to 0 of 1 over 2 plus h minus f of 2, which is plugging in 2 into the function, plugging in 2 into f of x, all divided by h. And I hope we got some algebra lovers out there, because we've got a complex fraction here. We've got fractions inside of fractions. We love fractions so much that we have multiple layers of them, like a wedding cake, but with fractions. Actually, wedding cakes are not really cakes inside of cakes. Although a cake inside of a cake now sounds really good. Any bakers out there, I charge you, make one and tell me how it goes. All right, we need to simplify complex fractions. There's a couple ways to simplify complex fractions, but usually one of the best ways to simplify complex fractions is to multiply by the LCD. Okay, that's what we need to do here. Multiply by the LCD. The other way is to combine the fraction on top. So the LCD here is a little hard to find. And again, if you're not comfortable finding LCDs, you need to reach out to me and I can give you some extra resources on finding LCDs, because it is important here. All right, so the LCD here is going to be 2 times 2 plus h. And almost always, it's just going to be one of the denominators times the other denominator, okay? And in fact, that will always be a common denominator, just not always the least common denominator, but it's a good bet. So if you ever feel stumped finding the LCD, just do one denominator multiplied by the other denominator. And if we do it in the numerator, we have to also do it in the denominator. Okay, so now we have to multiply this guy by this thing. This will be distributing. Let's distribute this. So we're multiplying a fraction by something that's not a fraction, which means the second thing, this guy right here, just goes in the numerator. All right. So it doesn't really fit on this page. It's going to be a little tricky to flip between pages here, but we're going to get the first thing, which is this fraction with this in the numerator, 2 times 2 plus h over 2 plus h. Jason, you're forgetting your limit again. Don't do that. The limit as h goes to 0 of 2 times 2 plus h over 2 plus h. And for the other one, it's this times this. It goes in the numerator, so 2 times 2 plus h divided by 2. Oh, I forgot to undo the circle. And the denominator is still h times 2 plus h. So again, this is a very common thing in math. That was a lot of math. And it looks way worse. You say, Jason, why are we multiplying by the LCD? This looks way worse than how we started. Well, here's the magic for multiplying by the LCD and why we do it for complex fractions. Look at this numerator. 2 plus h cancels away. We have the limit as h goes to 0 of just now 2. All right, that's a heck of a lot better, all right? And look at that second fraction in the numerator. 2 divided by 2, that cancels out. We're just left with 2 plus h. I'm getting a little nervous here. I feel like I messed something up, but maybe I didn't. I think we're good. And what is the denominator? It's h times 2, which is 2h, times 2 plus h. Be very careful. We cannot cancel here. We cannot cancel because the numerator is not factored. Remember, it needs to be factored before canceling, okay? Need to factor before canceling. All right. And the top is just going to become 4 plus h. And I'm actually a little confused as to something that happened over here. Let's just do a little recap right now, okay? So we use the definition. We plugged in x is equal to 2. We plugged in x is equal to 2. 2 plus h becomes this fraction. 1 over x becomes this fraction. And we multiplied by the LCD on the top and the LCD on the bottom to eliminate the complex fractions. All right, so the bottom is going to be 2h times 2 plus h. And the top canceled 2 minus, there we go. There we go. It's going to be the first thing minus the second thing. All right, so all right, that eraser is just too darn big. First thing minus the second thing. And if you are in a similar position to me and you see that something is happening, go back and check your work. If you're getting stuck, if things look even worse than normal. And remember that we're subtracting this whole fraction. So this whole thing needs to be in parentheses getting subtracted. Let's simplify a little bit more. The limit as h goes to 0. At the top becomes 2 minus h. That negative gets distributed. And now we get what's going to become a very common theme. We get some canceling. Plus 2 minus 2 cancels out. So we're going to get the limit as h goes to 0. Time to get excited, guys. Of negative h divided by 2h times 2 plus h. This is now fully factored. Since it's fully factored, that means it's canceling time. All right. So it's going to be the limit as h goes to 0 of negative 1 divided by 2 times 2 plus h. The h's have been canceled. We now have a rational expression. The limit of a rational, we can plug in and find it at that function value. So when h is equal to 0, right, as h goes to 0, what do we get? Well, as h goes to 0, this thing just goes away and we get negative 1/4. Negative 1 over 2 times 2, negative 1/4. So the slope at that point is -1/4. Remember, this is the slope when x is equal to 2. Slope is derivative. Woo. And there we go. Nice long video if you wanted some extra examples. And this is going to be tough. So if you have a radical, if you're looking at a problem with a radical, this is the trick you're going to want to use. Multiply by the conjugate on the numerator and the denominator. If you have a problem that's rational with fractions, what you're going to want to do is multiply by the LCD, just like we did over there. So those are two common tricks that you're really going to have to watch out for. Okay? And that's how you evaluate derivatives with the definition, with the limit definition. Good luck, and please don't hesitate to ask me some questions as you're working on some of these, especially if with all this messy algebra. What you can do is take a picture of your work if you get stuck and have me look over it for one of these problems. If you're somewhere in this middle section and just kind of feeling lost, that can be a good way to ask a question. All right, so you can just attach pictures on Slack pretty easily. Let me know if you have any tech questions with that. Anyway, good luck. Bye-bye.